Okay guys, we're going to have a look at amines. This is the first organic topic in module 2 of the upper 6th, the A2 chemistry spec. So this is, we're into A2, module 2. This topic is in chapter 5.9 of your textbook, and on the Firefly task I'll attach the past paper question booklet so you can use that as practice also. So this is the first video in amines. This is the largest organic topic on the A2 spec, so I thought it would be a good idea to start with this because we've been doing organic with me last term, so we just continue on. Okay, so amines, like all of your organic compounds, you have to know the general formula. That is, of course, the general formula there, so please guys make sure to learn it. You can see we've got the NH2, which is the functional group in amines. These can be essentially treated as substitution products of ammonia, so substituted with alkyl groups. So if we take ammonia as so, okay, and you can see that in ammonia we will be removing hydrogen atoms and replace them with either alkyl groups, so alkyl groups being your sort of your methyl, ethyl, etc., or with aryl groups, which are benzene substituents. Okay, so either of those will turn these things into amines when I remove 1, 2, or 3 of those hydrogen atoms there. Now, we have 3 different types of amines you need to know. We have primary, secondary, and tertiary. Probably not that difficult for you to work out which is which. So primary, very simply, we substituted one of the hydrogens, with an R group. Secondary, we substituted 2, and of course in tertiary we have on the right hand side there substituted all 3. So when you're deciding whether it's primary, secondary, tertiary, you simply find the key nitrogen and work out how many alkyl or aryl groups have been substituted off it. Okay, so I will pause the video when we come to questions, guys, and if you have a go at them, and then in fact, or alternatively you can skip on through, okay, and come back and do the questions at the end. It's up to you. These are all textbook questions, so you will have the answers to them. So you pause the video. Pause the video. Okay, so naming these things. So naming these things causes a bit of difficulty because there are a few different ways to name them. But I have spoke to Sia, and they're going to be fairly lenient on accepting names for these in the summer examinations. So you generally tend to get systematic name, which is the IUPAC name. Okay, you can also name them via alkyl or aryl followed by the term amine. That's non-systematic name. Or alternatively, if they are low priority group in it, you can name them by amino and then the alkane, or the name of the alkane, or the arine. Now you can also get an N in here, okay, in part of the name. That indicates that there's bonding to the amines nitrogen atom. Okay, now we'll look at examples of these, and this will all become a bit clear when we look at examples. So if we take a look at this, and you might want to have a little practice here naming these in all 3 ways. We're going to do some naming exercises from the textbook anyway. So first one, okay, we can call it, if we go via this, number 2, I've got these quite in order, but that's number 2, methylamine, so very simple. Okay, number 3 here, amino methane, dead easy. And then the systematic name, the one that you probably want to practice the most, methylamine. Okay, remember, no E between the prefix and the suffix there, because we have a suffix starting with a vowel, an A. Okay, let's have a look at this one. This one's slightly different now. You can see, well, you can see simply that it's a secondary one. Hopefully you can. There are 1, 2 carbons on the nitrogen. So this one is called, if I was to go via number 2 up above, it's called methyl ethylamine. So the methyl group here, okay, is attached to what was originally ethylamine. It can also be called N-methyl because there's a substitution that's taken place on the N. So if I started off originally with ethylamine, we have a substitution which has taken place on the nitrogen, which is a CH3, so we call it N to show that the substitution hasn't taken place on the carbons. N-methyl aminoethane. And finally, the systematic name is called methyl, and then the parent molecule, the longest chain, methyl ethane amine, again no E. Okay. Next one then, we can see is a tertiary. Okay, and we have our parent molecule for this would have been CH3, CH2, NH2, and we can now see we have two substitutions, one there with the C2H5 and also one there with the C2H5. So that's called triethylamine. Okay, that's what it says under the writing there. Triethyl, so we've got three CH3 groups, as you can see, 1, 2, 3, triethylamine. You can call it NN, so showing that two substitutions have taken place on the nitrogen. Okay, so this nitrogen originally had two hydrogens here and here, so now I've got two substitutions. So NN diethyl, both ethyl groups, and the parent molecule was aminoethane. Alternatively, in the systematic name that you probably use is NN diethyl ethane amine. Okay, so again, let's have a look at another one. So the only reason I've chosen this one is because it's a diamine, and it's just really to show you now that when it's a diamine and the suffix starts with a consonant, we put the E in there. So it's a one carbon diamine, methanediamine or diaminoethane is non-systematic. Okay, here then we've got 1, 2, 3. So again it's a diamine, but I've just done this because now we need numbers. So it's propane, and again we have the E in there. Propane 1, 3, diamine. Okay, so there'll be some naming tasks that I want you to have a go at, guys. So it's either do them off the screen or it's exercise 5.9D and 5.9E on your board. So if you just pause the video and have a go at that. Pause the video, have a go at that. (5.9F) there, sorry, 5.9F. Okay, physical properties of amines then. So let's have a look. First one, they have boiling points which are higher than hydrocarbons, aldehydes and ketones. Well, you should hopefully have picked up now that your amines have got NH2 groups, and NH2 groups will of course allow for hydrogen bonding. If you note, you only need to talk about the physical properties of the primaries. Those of you who are really on the ball might realise that if it was a secondary or a tertiary, let's take a tertiary here. Okay, it's an N, so we would have an R group there and an R group there. That means that there would be no hydrogen bonding in these tertiaries, okay, because the NH group has missing. If it was a secondary, the hydrogen bonding would be reduced because I only have one hydrogen bonding site now. So primaries have good hydrogen bonding, so they've got higher boiling points than hydrocarbons, aldehydes or ketones, because obviously hydrocarbons only have van der Waals forces, aldehydes and ketones have van der Waals plus permanent dipole. Okay, provided they're not too large, they're fairly soluble in water, again for the same reason. You have of course the lone pair of electrons, the nitrogen, and you have the very delta positive hydrogens, which can of course form hydrogen bonds with water molecules. Okay. Once that carbon chain, you all know this, I mean, once the carbon chain here goes sort of greater than about 4 carbons, then solubility falls away. Okay, so that's just the diagram showing the NH, the delta positive NH, and the delta negative oxygen forming that hydrogen bond. Okay. And they have a very characteristic fishy smell. They smell pretty bad, like rotten fish. They're horrible smelling things. Okay, so a few questions here then. 5.9b is the exercise that we're doing now. 5.9c. 5.9c, question 3. Okay, and that takes us up, guys, to the end of video 1. So that's an introduction to Amines. Please make sure you read through your textbook. Please make sure you do these tasks, and most importantly, please make sure that you mark these tasks and check your answers. And if you do have any queries, that you need to talk to me during our Zoom lesson.